Hi everyone, it's Has, and today we are going to continue with our Abaqus tutorial, and this is going to be a modal analysis. So let's start with our geometry. I am already on part here, so I'm going to stick with it. Then I will click create part, then 2D. But I think it's better for me to go for 3D so I can assign some thickness, right? But let's just give a name, which is a plate. I'm going to create a plate. Here, deformable. Yeah, so here I will choose shell instead of solid because if I choose solid, I will have a 3D part here. I don't want to have a 3D part here. I want to have a shell. That means it's a 2D part here that will act as a 3D. That means we are going to assign a thickness. We won't see it in the part because it's gonna be as a shell, all right? But we will assign the thickness. So if you guys understand didn't understand the thing about the solid and shell, you can ask in the comments and I will explain you. So shell and then continue. Now I have the workbench where we will draw our geometry. I will take the rectangle so I can create my plate, right? Then I will take dimension. Here is gonna be 1 meter, 1 meter, but I will assign it as a millimeter, right? So as a millimeter, it's going to be 100. 1,000 millimeter is 1 meter. So then I will take this part and I will assign, let's say, 500, right? 500. So now we finish with our plate. So what I can do right now is to click on here and then done. I will have my part. This is my shell. So the second thing to do is the property, right? And the property I will create, it's an isotropic material, which is a steel. It's a steel. And then general, I will give the density, right? So 7.1.8 E minus 6. So what I will do right now is to go on mechanical and then elasticity, mechanical, elasticity, elastic, then the Young modulus in megapascal, so 220,000, and then the Poisson ratio, which is 0.33. So now we finish with our property. Okay, what I will do is to create a section, create a section which is a shell. Our section is a shell. So let's say section 1, let's leave this name, and then it's a homogeneous because it's isotropic, so homogeneous. So continue. What I would do right now is to pull the thickness. So the thickness is 0.001, So this is my thickness. Yeah, but this is in meter. But it's better to have the thickness in millimeter. So let's say 1 millimeter. Yeah, 1 millimeter. So this is our thickness, 1 millimeter. And then it's a steel here. I will give OK. So now we create our section, but I didn't assign it yet, but I just created. Now I will assign the thickness of my section to this. So the section is the whole thing, So I create not only the thickness, but the whole section and then done. So you can see here, I have section 1. This is the one I created. Then, okay, you can see the change in color. That means my section is being applied. So we finish with our property. The third thing to do is to assembly. We all know that by the rule, we need to create an instance here. We just click, you don't click anywhere else. You just hit OK. So now you can see your part here. That means the instance is being created, right? So what I would do right now is to go on step. So this is one of the very important step because the step is what's going to define the work you are going to do. So as I said, it's a modal analysis on my plate. So I will click on here to create a section. a step, sorry. So I already have initial step. So the initial step is not what I'm going to use, because basically when you apply boundary condition, you need to apply some step here to create some step so you can apply your boundary condition, right? So what I will do right now is to create step 1, and then I will take not static general, because static general is like if you are going to apply loads and then linear analysis or non-linear. It's not what I'm going to do, but I will change the general here and go to linear perturbation and then frequency. So if I take frequency, I can have the modes, the natural mode of my plate. So that's what I want to do, and then continue. So now everything is fine. I can hit the other here. Everything is okay. So then, okay. Now, following, there are some missing parameters value. The maximum frequency. So here, we didn't even assign the number of frequency or number of cycles that we want. So let's say I want to have 20 or 10. Let's say 10. I want to have the 10 first frequencies, right? So it's going to be 0, 1 to 10. So then you can see the frequencies, the 10 first frequencies. If you want to have see the 50, you can put 50 in here, but I just chose to put 10, right? So now what I would do, block size default, it's fine. Maximum number of block default, yeah. Okay, so now we finish our step. What I can do is to go on load. So now I can create my boundary condition. So we can see that our plate is along X. I mean, the, how to say, the higher length is along the X axis. So I will block my parts in the other directions, but not on X, because my plate is along X. So I will hit here. I will take displacement, because in this way I can free the direction that I want and then block the one that I want, or the ones, because they are going to be two to be blocked. So boundary condition, let's say left side, right? Boundary condition left, and then continue. I will click on here and then done. So if I keep done, as I say, I'm going to let free at U1, because this is X, and now we to block U2 and U3. So U2 and U3 are Y. No. I say Y. It's in French, we say Y. It's Y and then the Z. U2 is the Y and U3 is the Z. So I will hit here. I will create another one that I'm going to give a name, which is right. And then I keep displacement. Then this right side, done the same thing here. So the rotations, we don't need to count on them, because in modal analysis, we don't really count on them. We can as well block them, but it's fine for this analysis. We can just leave them. And we will see based on of the results, we can still block them, because natural mode can be about the mesh, can be also about the boundary conditions, the way you have the result. But this is a little bit advanced to explain you about this. But if you guys really want to know the crucial factors that the boundary condition play on the model analysis, you can ask me in the comments. Maybe I will do another video to really go in detail about that, or just answer if it's short. So it's gonna depend. But right now, you just need to know this. You don't block the along the X, because this is the higher, let's say the higher length. It's along X. So you just block the other axis. Then okay. So now let's go to mesh, because there are only the constraints, right? There is no load applied, nothing. That's in natural mode, so you don't apply any loads. So now the mesh, you need to be on part first. So you have the changing color, so that's fine. You hit here, approximate global size, it's 100 here. That's not what I want to have. Let's say 8. If I hit OK, no, let's say 100. Yeah, let's see how it's gonna be. No, I don't want to have 100. So let's say 50. Yeah, I think 50 is okay, but let's go 35. 35 is way more better. So now I can mesh my part. Yes. So this is okay for me. So I don't know if I exceeded the number of nodes, but we will just see. Let's go to the job. Yeah, let's go to job. No. You click on here, job. We don't even give a name. Continue. So now, okay, I will go to the manager and then I will submit my work. So why do I have this? I don't understand why do I, yeah. So now let's just wait for a few seconds. So obviously we have results. So now you can see here completed. So we have results. We can hit here results and you hit here. So we can see this is the displacement, but what we really want to see are the number of nodes and the frequencies we have on each mode, right? So you hit on results here and then step frame. You see all these number of nodes here, number of modes, we have so many, 52. So it's fine. Even if we have specified 10, but we can see that we still have a large number and many modes that still are put under C. That's why I have many. So 0 to 52. So always the first one don't give us anything, right? This is the first one, the 0, there is nothing. And even I don't think this is not counted. We count from the first one. And the first one is always 0. I mean, most of the case. But all the analysis that I've done, I always have 0 on the natural, the first one. So basically, the second is like the first because the first is always 0, right? So this is the second. You can see the value of the frequency here, So from here, and then you have all of them. So these are the number of modes that we have. So we can see that they are quite lower, right? So this is 10, and 10 megahertz, and all of them. These are megahertz. So now we're good. So I will just hit OK. Or if you want to visualize the, let's say the plate on, let's say mode 5, you put on 5 and then you hit apply. You can see the plate here on this number 5 mode. You can go on the 29 and then you can hit apply, but let's just reduce the size. You hit apply, you can see. So as we go to the other modes, they increase. We still increase. So the higher the mode is, the higher the frequency is. That means the lowest frequency we have is from the mode 1 and then the mode 2 and so on. So if, for example, we go to the mode 45, you can see that it really changed a lot. If I hit this and then I turn it, you can see. But if I go to the first one, we can see that nothing, right? Nothing. Why? Because it's 0. So we don't see anything. That's why I say basically when we do this analysis, the second one is like the first. So now we have some color, even if there's no really big change because it's almost 0. It's not really 0, but it's 0 something. So it's fine. So even the number 2, but we still have some value, right? So the number 3 is, a little bit. So we start having all of these. So there are other factors that I can explain you about the modal analysis. There are factors that we can see the number of circumferential modes and some other ones. I mean, there are basically 2 ones. If you want to know those 2, you can just ask me in the comments. I will maybe answer you or do another video to really explain you the post-processing of these. So I hope that helps. That's how you set modal analysis on Abaqus, and I hope that you like it. Don't forget to subscribe and to like. Thank you, all of you guys, for watching this, for the support, and peace.